Welcome to the first hearing of the year on the Subcommittee of Chemical Safety, Waste Management, Environmental Justice, and Regulatory Oversight, and with a particular emphasis in this subcommittee hearing on the challenges that we face in regard to plastics. A special welcome to our ranking member, Senator Mark Wayne Mullen of Oklahoma. Thank you for your preparation for the work of this subcommittee. Mass production of plastic began in earnest during the days of World War II. It continued to boom in the decades that followed, heralded by many as a bold new frontier in material abundance thanks to its versatility, its durability, its inexpensive cost of production. There's a scene from the movie The Graduate where one character speaking to another says, "There's a great future in plastics. Think about it." Well, now, decades after the filming of The Graduate, we've had a chance to think about it, not only to think about it, to experience it, to live it, and to know that with this particular material comes not just a variety of potential uses, but a significant number of problems, of challenges. And it's our responsibility to understand these problems and seek a way to address them. We know that one of our problems is the massive amount of greenhouse gases emitted through the entire life cycle of plastics, from its extraction and transportation of the raw material of methane gas to the greenhouse gases produced in the process of refining and manufacturing to the management of plastic waste through incineration. Many folks just don't connect that plastics are closely tied to the petrochemical industry. Fossil fuels are part of nearly every stage of plastics production. It takes the raw feedstock and chemically refines them, turns them into polymers, which become the building blocks of plastic manufacturing. So right from the start, the very first step in creating new plastic is pulling fossil gas out of the ground. It contributes to an increase in methane being released into the atmosphere through that massive network of pipes. And over a 25-year period, methane is 80 times more efficient in trapping heat than carbon dioxide, ounce per ounce. And then there is another challenge: the unthinkable amounts of waste. It's estimated that, well, at least 3/4 of the plastic ever produced has ended up as waste. And now the ratio has grown to something close to 90% of the plastic produced ending up as waste. We always hear the mantra of the 3 R's: reduce, reuse, recycle. But less than 10% of our plastic is actually recycled. And that's despite the blue bin program. And most of the plastic that you'll put in that blue bin it's referred to as wish cycling. You put it in wishing that it's going to be recycled, but the reality is that in most cases it is not. So instead of the reality of 3 R's, the true case is the 3 B's. Plastic is burned, it's buried, it's borne out to sea. And in the process, it creates public health and ecological challenges. Each year, thousands of seabirds, sea turtles, seals, other marine mammals die from ingesting plastic or getting tangled up in plastic. Fish in the Pacific Northwest ingest an estimated 12,000 to 24,000 tons of plastic annually. Plastic pollution often comes in the forms of lumps, but it also comes in the form of microplastics. And microplastics have now penetrated every system on Earth, in the water, the soil, the air, our food systems, even our human body. They've made their way into our lungs, into the breast milk we feed our babies, into our bloodstreams, and that produces a lot of public health concerns. Plastics have more than 10,000 chemicals associated with them, over 1/4 of them having potential health risks, including chemicals that mimic, block, or alter the actions of hormones, reduce fertility, and damage the nervous system. It's estimated that each of us consumes about a credit card worth of plastic every week. And I don't think there's a person in America who likes the idea of envisioning their children eating a credit card worth of plastic each week with all the chemicals that are in it. So it gives us pause. The fossil fuel industry is envisioning a massive increase in the production of plastics, but that will only amplify the problems, and it makes it even more urgent that we address them. That we work to protect human health and to protect the integrity, defend the integrity of our ecosystems. So we have to understand, increase our understanding of the challenges and explore ways to address those challenges, to solve those challenges. And that is the purpose of these hearings. We'll be doing about a series of 6 hearings. And we're fortunate to be joined by several witnesses who will kick this off. Dr. Arvind Ravakumar is co-director of the Energy Emissions Modeling Data Lab at the University of Texas, Austin, which seeks to provide reliable, science-based, transparent, and measurement-based greenhouse gas assessments of the global energy supply chains. He's also a member of the Sustainable Energy Development Lab, which focuses on developing technical, social, and policy solutions to effective climate action in the global energy sector. With Dr. Ravakumar, we have Dr. Chelsea Rockman, assistant professor at the University of Toronto, St. George, where she spent the past decade researching the sources and ecological implications of plastic debris in marine and freshwater habitats. Dr. Rockman runs a program researching plastic pollution with a major focus on the sources and pathways of microplastics and other contaminants into urban watersheds and Arctic ecosystems, as well as the effects of multiple stressors on ecosystems across all levels of biological organization and solutions to reduce plastic pollution. They are joined by Dr. Hota Gangarao, and he will be introduced in detail by my colleague. Thank you all for being here this morning.